All right, guys, here I go. I'm going to try to do this in under 10 minutes, but I'm guessing it's going to take 15. But it's my lunchtime, and so I'll try to be thorough yet effective. In your notes right now, pause this and fill out the following headings: percentiles, cumulative, relative frequency graphs, and z-scores. Next, your goal. Your goal is I can use percentiles to locate individual values within distributions of data, interpret a cumulative relative frequency graph, and find the standardized score of an observation, as well as interpret the z-scores in context. Pause it now and write down the goal, and then glue down example 1. When you read example 1, it says the stem plot below shows the number of wins for each of the 30 Major League Baseball teams in 2009. So stem plot 5/9 represents a team with 59 wins. The problem here says find the percentiles for the following teams: the Rockies, the Yankees, and the Kansas City Royals and Indians. Well, first what you need is the percentile definition. So please write this down. The percentile definition is the pth percentile of a distribution is the value with p% of observations less than that. Let me give you an example. If you are in the 10th percentile, that means the 10th percentile of a distribution is the value with 10% of observations less than that in the group or in the population. So A, if we look at A, the Colorado Rockies, who won 92 games. What I'm going to do right now is I'm going to use my highlighter. Or should I use my pen? Just kidding. I'm going to look at 92. So 92 is right here. I know that there's 30 total Major League Baseball teams in this distribution. So I'm going to count how many teams are less than 92. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So what I do now is to find the percent of observations less than that. 24 less than 92, 30 total. I divide it, and that's 0.8, or the 80th percentile. I don't care if it's in decimal or percentage form. Letter B says 103 games. 103 games is right here. I know there's 30 observations, so that means there's 29 observations less than that. Divided by 30 gives me 0.96 repeating, which is approximately 97% if we round. And then part C, the Kansas City Royals and Cleveland Indians both won 65 games. 65 is right here. There are 3 observations less than that. So I do 3 divided by 30, which is 0.1, or 10 percentile there. Pause it right now, kind of look over your work, make sure you understand anything, rewind and listen again if you need to just hear it one more time. I'm going fast to hopefully help you so it's not so long. Write down any questions that you have and come with it for class tomorrow. A cumulative relative frequency graph is your next heading. Example 2, please glue this down, ages of U.S. presidents. Pause, glue, and then I'll explain. So, ages of U.S. presidents was President Barack Obama, who was inaugurated at age 47, unusually young. Estimate and interpret the 65th percent of the distribution. Okay, so here we have a cumulative relative frequency graph. Down here, you can see the ages at inauguration. Part A asks for President Barack Obama, who was inaugurated, at age 47. Was that unusually young? 47 is approximately right here. So I draw my line up because that's my age. So at 47, because that's Barack Obama, I draw my line up, and then I draw across. Okay? Now I'm going to actually erase that. Re-looking at that, this goes from 45 to 50. I think I got more 46, and maybe I'm being picky. But I'm going to go a little bit more up. Up, and then I'm going to use my straight line because that's going to make it look nicer here. And let's use blue to keep it consistent. So the answer, I would say, for part A was President Barack Obama, who was 47 at inauguration, unusually young. It looks like he's in about the 10th percentile. Now the question is, oh, I put 11th percentile, looks. I'm going to change that to 10th, approximately, right? Give me 1 second here. I'm going to change that to about 10. I'm going to actually type it out here. Should have done that to begin with. Forgive me. And I'm going to say President Barack Obama was in, or is in actually, you English people can help me here, there, is in the 10th percentile. This is not unusually young. Now, how do we know where the cutoff should be? The benchmark here is 5%. If it's below 5%, then we say it's usually unusual. Now, part B is going the other way. So if you're not ready for part B, make sure you pause and go from there. Part B is estimating and interpreting the 65th percentile of the distribution. So I'm going to go backwards now, okay, because they don't give me an age, right? They don't give me an age. They actually give me a percentage. 65th percentile is approximately right here. I'm going to draw my line. Wow, that was an awesome line. Let me redo that with a straight line. 65th percentile is approximately right here. And then I'm going to go down. And it looks like the age for the 65th percentile is approximately between, let's say, 57 and 58. Let's see what I put. Dun, 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 dun. And I did put that. So going backwards, the 65th percent appears to be 57 or 58 years old. Notice my language here with appears. Okay? Notice my, and I should have actually put here, not is in the 10th percentile, but looks like he's about in the 10th percentile. Okay? So about needs to go in there somewhere. Pause right now, look over it, re-listen to it if you need to when dealing with a cumulative relative frequency graph. Write down any specific questions you have and come ask tomorrow in class. Excuse me. Now we're off to z-scores. Pause if you need a second to catch up and glue down example 3 right now, please. In 2009, the mean number of wins was 81 with a standard deviation of 11.4. And that we're dealing with baseball right now, okay? The problem is find and interpret the z-scores for the following teams, the New York Yankees and the New York Mets. Ooh, I do not like that color. All right, that's prettier. First, you need to know what a z-score is. A z-score is the exact standard deviation of an observation is below or above, there's a typo here, above the mean. Okay? The further the z-score is from 0, the more unusual it is. In fact, we have another benchmark here. If you have a z-score of 2 or -2, that is an unusual observation if it is a normal distribution, and that's the key there here. If it's a normal distribution. Now you may be asking, well, how do I know if it's normal? It will state in the problem, given this is a normal distribution, or somehow it will say. Okay, so 2 and -2 is your benchmark if you're dealing with a normal distribution. For example, in this problem, it does not say anything about a normal distribution. So you can't really use that benchmark. You just say, wow, it's really far from 0, or it's not. A little more ambiguous. For those of you who don't like that, I'm sorry. Pause right now and catch up on the z-score definition if you need to. Now the next thing you need to know is the z-score formula. The z-score is equal to an observation minus the mean. I put in parentheses because it's really important you type it in your calculator the right way. And then you divide it by the standard deviation. So we're going to go now, pause, write that down if you need to. We're going to go down to part A. The New York Yankees with 103 wins. That's our observation right there. Okay? I know what my mean is. My mean is 81. And I know my standard deviation is 11.4. So, with that, I take my observation, 103, minus my mean, 81. I divide by 11.4, and I get a z of 1.93. Does the question ask to interpret it? It does say to interpret it. So if I'm going to interpret it, let me just add on to this for you. I would say an observation, and I'm going to change my font. Let's go with 20. An observation of 103 has a z-score equal to 1.93. This observation is 1.93 standard deviations above the mean. And that's how we interpret it. Okay? That's how we interpret it. Now, part B says the New York Mets with a win of 70 wins. I didn't do that one yet, so you can do that on your own to practice and come ask me tomorrow. But with part B, one thing I want you to notice, 70 wins is below the mean. So you're going to have a negative z-score. When you interpret it, then you'd say our z is equal to negative whatever you get. That means we are blank standard deviations exactly below the mean. And I want to be clear with your z-score, and you might want to write this down. A z-score does not have a unit attached to it. There is no unit because it's a standard deviation, an exact standard deviation. And standard deviations do not have a unit with it. Okay, so moving on. Pause if you need to re-listen to anything. I'm going to cross off part B because I don't want to waste more time. I want you to try it on your own. And I want you to glue down example 4. I'm going to read through it here. The single season home run record for a Major League Baseball has been set just 3 times since Babe Ruth hit 60 home runs in 1927. Roger Maris hit 61 in 1961, and Mark McGwire hit 70 in 1998, and Barry Bonds hit 73 in 2001. In absolute sense, Barry Bonds has the best performance of these 4 players. Why? Barry Bonds hit 73. Babe Ruth only hit 60. Roger Maris only hit 61. And Mark McGwire only hit 70. Okay? So reading on, of these 4 players, since he hit the most home runs in a single season. However, in relative sense, this may not be true. Baseball historians suggest that hitting a home run may have been easier in some eras than others. This is due to many factors, including quality of batters, quality of pitchers, hardness of the baseball, dimensions of the ballpark, and the possible use of performance-enhancing drugs. To make a fair comparison, we should see how these performance rate relative to other hitters during the same year. So what you would need to do here is it says compute the standardized score for each performance. Which player had the most outstanding performance relative to his peers? We don't have enough information here, to be honest. What we need is the average home runs in 1927. We need the standard deviation in 1927. Why? So we can find a z-score for 1927 for Babe Ruth. Then what we need here, and let me cover this up so you're not writing while I'm talking. Come on, let's drag that down. I have the same problem in class. Okay. Next, what you would need is to find a z-score for Roger Maris from 1961. You have your observation, you need your mean, and you need your standard deviation. Then you'd get a z-score for Roger Maris. Remember Babe Ruth, observation is 60. You would need a mean and a standard deviation for the year 1927. Next, you would do it for Mark McGwire. His observation is 70. You would need the mean of home runs in 1998 and a standard deviation of home runs in 1998. You'd find Mark McGwire's Z-score. And then finally for Barry Bonds, you would need the mean of 2001 home runs, the standard deviation of 2001 home runs, and you have the observation. So you would find the Z-score. You would find 4 Z-scores, which is standardizing it, and you would compare which one is furthest from 0, meaning which one is the furthest from the average or the mean. Now you can write down what I put formally. Standardize both scores. That's an error. Sorry, you writers. All scores, so there's 4 of them, relative to each observation's population. What do I mean by that? I mean each year. You find the Z-score and then ask which Z-score is more extreme. In this case, we would say most extreme. Thanks for bearing with me on that one. And then finally, example 5. Competitors A, B, and C are competing in the decathlon. So pause right now, re-listen to example 4 if you need to. Write down specific questions, please. In example 5, competitors A, B, and C are competing in the decathlon. After 3 events, who turned in the most remarkable performance in this competition? I want you to notice a couple things. We have the 100-yard dash, we have the shot put, and we have the long jump. Okay? What you are going to do first is you are going to find, let me change, the Z-score for each competitor. Oh dear. For the 100-yard dash. Then you would do it again. Repeat the process for the shot put. And then repeat the process for the long jump. Now you need to notice something in particular here. I do give you the means, okay, right? So the means are all here for each event. And I do give you the standard deviations as well as the observations for each competitor. So you can find the Z-score. I am going to have you pause and do that on your own in a second. We'll talk about it in class. But there's something really important you need to notice about the long jump. You'll notice that I have different units here. Here's 6 inches, here's 27 feet, and 3 inches. If it was me, I would change these all to inches. So right now this is 26 feet. You know, there's 12 inches in a foot, so I'd multiply this by 12. Why am I doing that? I need all the same units at least when I'm finding a Z-score. Pause and do that now for me. You're changing all of these observations to inches. Okay, now off to your next step. Step 2. You now have a Z-score for each event for each competitor. You are going to add up the Z-scores for each event for each competitor. But before you do that, we need to talk about the 100-yard dash. Those of you, oh dear, I didn't want that, forgive me. Those of you who run track or anything that has to do with time, know that in this case you do want to be below the mean. Okay? But in the shot put, you want to be above the mean, as well as the long jump, because there you're going for above the mean, farthest away from the average. In running, though, anything with time, you want to be below the average. So what I want you to do is I want you to take the absolute value of these Z-scores. After you take the absolute value of those Z-scores, then what I want you to do is add up the Z-scores for each competitor in each event. So you'll have a total z-score, for competitor A, B, and C. Then compare them and see which one is the most outstanding. At this point, rewind, listen to this part again if you need to. I think I was clear, but if I wasn't, write down specific questions that you need to come to class with tomorrow. I do expect this problem done for class, as well as the one question Schoology exam that I'll give you. I made it in 20 minutes and 39 seconds. Forgive me, I went over like usual, but hopefully this helped. Thanks, guys.